Hello, everybody, and welcome to today's presentation, Gain a Competitive Edge with an Open Source, Purpose-Built Time Series Database, brought to you by Influx Data. Now I would like to introduce you to our presenter, Daniella Pontes. Daniela is currently working at Influx Data in San Francisco. She started her career in telecommunications, wireless technology, and global internet service provisioning. As security became a major concern for enterprises, she worked on enterprise policy management, SaaS, and data encryption solutions. Prior to joining Influx Data, she spent some years living in Japan, Germany, and Brazil, working for an online agency developing and managing the Brazilian market. Having worked in various market segments from embedded smart antenna technology to internet security and e-commerce, doing product management, partnerships, marketing, and business development. She has a broad experience working cross-functionally and with customers and partners.
Okay, thank you. Good morning, everyone. This is Daniella Pontes. I'm part of the product marketing team in Influx Data. And today we are going to have a conversation, more like a monologue, about open source, purpose-built time series database and why this gives you a competitive edge. To guide this talk, we have four main topics. One is why we collect timestamp data. Why is this relevant? And then we will describe what constitutes a time series data set. Is anything that has a timestamp time series data? To address this kind of data set, there are lots of solutions in the market. Some of them are legacy, and others, they came about to deal with time series. And we will talk about the differences. And then we will enter the Influx Data data model, Influx DB data model, to show you what means to be purpose-built. So, is timestamp data something that we just started collecting? Of course not. Yeah, humanity has been collecting timestamp data for a long time, and that's why we know that global warming and that the ice caps are melting. It's not fake news. We have been collecting data about it. So why now is so relevant? And we identified three main driving forces that makes time series the topic of the time. One is IoT. Of course, everybody hears about the explosion of IoTs and sensorization of the world. And even in that segment, we describe two driving forces there. One is the IoT applied to industrial settings and to the grid there for renewable energies. And they are there in the field, collect information about themselves, about how they're operating, about the environment around, and about the service that they are providing. And all this data goes back to be analyzed, so the providers, they can make better decisions about, what to produce, when to produce, and if they are actually providing a good service. But there is another segment in the IoT, I would say, market, which is what we call consumer IoTs or wearables. In this case, the difference is that the time series is actually the service. It's not the device, and the UI is just a wrapping. But when you wear a device that tells you how well your heart is doing, if you are, consuming the calories that you ate, that you are exercising well, what you are consuming in reality is a time series about yourself. So this is a tremendous driving force about collecting data on a time base. Another driving force is what's going on with DevOps and Ops in general. We have heroes there in the background. They deal with cloud, public, private. They deal with still with on-premise infrastructure, and if that's not enough for added complexity to what you have to deal with, you have the componentization of applications, and they because now everything needs to be done quick and fast and competitive, the developers figured out, yes, okay, we can do that. We break the application into little smaller services, and we update them in isolation. And by the way, everything needs to work fine when they are talking to each other. So this added a lot of complexity to the infrastructure environment, to the application running environment. And in order to keep everything running, you need to collect data about everything, about every microservice there, every interface, every link, every device. And this is just exploding in terms of time series data set that is being collected. But the pressure is not just from behind the scenes. The market is demanding a lot of responsiveness in the network from the networks, and also it's not just that the applications are being componentized. We have the business now divided into business use units that demand monitoring as a service to them as well. So they can make better decisions, educated decisions in terms of how they should drive their own units. So DevOps and network operating, IT operations, they are receiving a list of demands in terms of what to monitor and what kind of key business indices they need to collect, so the rest of the business can run well. And on top of that, there is the pressure from the end user. Yeah, nobody now accept any delay, any degradation in performance, no matter what is going on in the world. So if when I click on a button, I don't get a response in 1 second, okay, bye. I will find someone else that can serve me better. So the streaming force is creating a huge demand for time series, and now we need to deal with it. So this is just to endorse a little bit this statement that time series and the timestamp data is something that we have been collecting, and we are collecting even more. This is a survey done by Dzone and shows that 80% of the professionals that were interviewed affirmed that yes, we collect time series data. How they are handling it, we will see later. So now let's get into understanding better what is time series and how it behaves. Yeah? There are two main kinds of time stamp data that you collect. One that you collect at regular times, so every 5 minutes, every 1 minute, and another one that you collect when it happens. The ones that you collect as regular time, we call it metrics. We like to call it metrics. And the ones that just happens, we call it events. And you need to be able to manage these two kinds of timestamp data. And later on, we will see that that's not the case for every solution out there. So keep that in mind. Here is just making official. Yeah? We have two different kinds of timestamp data. One is metrics, regular time series, and one is event, irregular time series. Metrics is more like, collecting the performance of your network, your CPU, your memory, and events it could be both. It could be from an event in your network, a peak in traffic or a failure, but event is also a click, something that is triggered by the user, human triggered. So it's important to keep in mind that there's two different kinds of data collected. Timestamp data or time series data have important characteristics that we have to take into account in order to make best use of it. One is that you can aggregate, you can summarize. And even though we collect data in regular time intervals like events, you can still, as a second step, transform that data into a regular time series. So let's say that you open a window of 5 minutes, and there you see how many times your network had a peak. And then the next window, you check that again, and the next window, you check that again, and so on and so forth. So you would get different sampling rates for, you will have you will get different numbers of events inside of those windows. But when you transform that series in a next series and saying that I want to just summarize what happened in this window, you now have a regular time series metrics. So this is important to keep in mind because it's a tool that you can use to aggregate your data and treat the data differently from when it happens to when you keep it for storage purpose or historical analysis. So let's see what we know so far about time series. First, that of course the data needs to be stamped with time. Second, that we have two major categories. One is the metric, regular, and the other one is the event type, irregular. But one thing that you always have to keep in mind, we are talking about huge volumes of data. And when you think about that, you need to think about, being smart when you collect, when you transfer, when you ingest, and when you store. You cannot think small when you think about time series, and you cannot think in isolation. Remember that time series being demanded not only by the operation teams trying to keep everything together, but also time series is a service on itself that has a value to the end user. And time series is also serving other units in the business, helping them to make better decisions. So you need to think big about it. You need to think how you're going to store that information. You need to think about how you're going to store it efficiently and cost efficiently. But another aspect of time series that should not be disregarded is that at time change, the value of things change in time. And you have the time handle there to maneuver your data. What you collect in real time has a value. As a day goes by, as a week goes by, a month goes by, that value change, and you may want to aggregate that data to just keep as a record of the profile of a certain usage, or just a record of the range where certain event happens. So you need to think in real time. You need to understand what's going on in real time, but you need to understand also and be able also to handle that information in another way. So you need to be able to aggregate, you need to be able to store in a different level of granularity. So knowing about why time series is relevant and the different characteristics of a time series data set, what are the databases out there? Well, a time series database, as we've seen so far, needs to be optimized for collecting, storing, retrieving, processing the data, and also dealing with the life cycle of that data. And what do we have in the market? In the market, we have the specialists. Yeah, we have document databases that are storing, take into consideration a JSON data format. We have search database, which the focus is to be fast about, searching full text. And we have the traditional relational database that they were more concerned about the contextual information about a specific data than, the repetition of that data over time, how it changed over time. So if we have a market of specialists, why would we try to take such a peculiar kind of data set like time series and try to put it into specialists that don't know what to do with the time access? So here is just to give you a small sample of the landscape. On the left side, you have other types of database that is in the market. Some of them are relational, some of them are, the NoSQL. That it has some kind of, I would say, progress in terms of handling data that is not just relational. Yeah, they use key value pairs for data model. They use columnar kind of structure, but still they don't treat time as a first citizen, and you need to do that, not just to avoid limitations and challenges, but to take advantage of it. In the time series scenario, we do have already a solution that came to market claiming to be, time series database and saying that they are using the time as their driving dimension. And we do have also, even in the time series database, the specialists like KX. They focus on the financial market. So for them, the important thing is to be fast. Yeah, when you are trading stock, you want to outrace, your competitor. You want to sell first or buy first. And we have other solutions in the market also like Graphite that they came from an older mentality in terms of monitoring timestamp data when you had the little silos there, the amount of data that you collected were not that tremendous. So you could handle with the RRD kind of solutions. But now the volume is just impractical. You need to be able to scale in volume and in speed. So here is another survey. It's just showing you that people use what they have on hand, and they prioritize what they know about, what they are familiar with. But more and more companies and organizations are utilizing purpose-built or time series database for their time series. So here we see around 12% and 18% kind of trying to use, non-relational but not yet time series, but the majority, it's still trying to get by with what they have in-house. Here is to show you that Influx DB, because it's a purpose-built kind of time series database, it does have a strong traction in that segment. And that is important to understand. And one other reason that makes it, a preferred choice is not just because it's purpose-built, but because it's open source. And this graph reflects that. Open source is very important. Why? Because you don't want to be surprised by a bottleneck in the solution architecture that you didn't know about. But open source is not just about being free. Open source is about being transparent. Open source is about being flexible for adaptation. And what's going on in the environment now is that you have this complex landscape of different kind of network, cloud, on-premise, a mix of the two. You have legacy applications that are now in containers, applications that runs in single servers. And you need to be able to connect to all of those pieces in all of those networks to collect data. And for that, you need to be flexible. You need to have multiple hands and eyes helping you. And having an open source community behind the solution that you pick is huge. So on the left side, this is more data. On the left side, we show that time series is actually the database of the moment. Yeah, a lot of professionals are looking into it. They see as something that they need to start to bring in-house to handle all that time series data that they are collecting to help themselves as a company and also to add new services opportunities. And you can see that time series is outpacing all the other segments. On the right side, it's again showing Influx DB right there on top, but it's not the reason of this. I have this graph here is not to show you that the Influx DB is the king of the hill. No, it's to point to an important fact that happened to the market. If you look on the bottom right there is a little line showing time stream. So Amazon announced last year that they are entering this market. They will offer a time series database solution. And this is a huge endorsement to the fact that time series is a kind of its own and deserves a solution that's a specialist. Oh, sorry. All right. So let's now talk a little bit about Influx Data. Why Influx Data is such what is the approach that Influx Data took to the time series solution market. So yeah, time series is not just about storing a huge amount of data. It's not just about collecting data. Time series deserves a platform strategy because it starts from the moment where you identify what you need to instrument, what you need to collect, and that needs to be done in a smart way. Because if you don't do it, in a well thought process, you will have trouble. You will not address your audience. You will not extract the benefit that you need from that data. Once you get that data, you need to think about how you're going to observe. So you need to make sure that you have a visualization tools that gives you the enough granularity to check on the data that you need and be able to create a report, dashboards that facilitate that observation. Think that you are dealing with a lot of things. You are dealing with from the host level to the network performance to the mixed environment to the end user experience, and you need to be able to monitor everything, and you need to be able to monitor everything in a way that makes sense to the audiences that you are going to serve. Of course, you need to learn. Just looking at it and not taking any insight from it, it doesn't pay off. So you need to be able to process that information and extract the next level of insight. So you need to be able to feed other kinds of solutions that takes time series as an input and can extract information that will give you another advantageous point of view. And of course, the ultimate goal is automate. Yeah, that's all we do in life is try to automate what we do today, so tomorrow we can do less. And it's not what happened. We know that as soon as we automate something, we find ourselves busy with other things. But anyway, automation is mandatory. It's not a matter of freeing yourself from work so you have more time for whatever. It's became impossible, because if you have such an environment with mixed kind of infrastructure, and also the visibility that you have in that infrastructure, in that network kind of environment is different. What you have in house, you can touch, you can look deep, you have access at any time. What you have in the cloud, that's a different deal. But at the end of the day, it doesn't matter how many SLAs you have in place, you are still responsible for the end-to-end experience. So you need to monitor everything, and you need to make sense of everything, and you need to react to everything. So you need to automate. So you can free yourself to think over what you need to do in order to take the next step in the next automation requirements. So let's talk a little bit more about what it means to instrument time series data. So you need to be fast. If you are dealing with time series in certain segments like financial, we are talking about nanoseconds. So you need to be able to get a solution, think of a solution that can ingest very high data rates or very, very high granularity. It has to go both spectrum. Yeah, you cannot think of only one little use case. You need to think about all those audience that you need to serve, and that data that you collect may not be in your network or in the cloud, may be spread in the field out there if you are dealing with IoT. So you need also to be conscious about what kind of restraint you have when you collect that data. And of course, when you collect this a huge amount of data from all over, you need to be able to store it, ingest it efficiently. You need to be able to store, and also compress over time. As we know that time drives in the value of data, you need to be able to apply techniques so that volume decrease as the value decrease. So you are not overpaying for storage. Let's see, observation. I have something in front of it. Okay. Observation is about being able to see what is happening when it's happening. Yeah. And so you need to be able to do query in real time, in large data sets. So when we are talking about time series, you're talking about very large range scans, and you need to be doing this in real time. While you are ingesting a lot of data as well. So you cannot degrade one aspect of your time series handling to handle another one. So learning is about being able to use that data, provide that data to a next level of understanding. Yeah. So time series it is in many ways, you know, the underneath of providing the foundation for a lot of machine learning solutions and platforms out there, anomaly detection, and also it is in the learning process when you do your analytics. You know, the analytics needs to be also in real time, and those are the processing power that will alert you early enough in a trend so you can react before your end user feels it. And the ultimate goal, automation. Yeah? And when you think about automation, you think about, you know, what you learn, what you extracted from your real-time analysis, and you can fit this into a workflow that is automated, that facilitates your handling of your network, of your services, or reaction to events. But also automation means to be able to deal with the full life cycle of your data. Keep in mind that as soon as that data loses its value, you need to be able to evict it. So you don't keep, you know, consuming storage and resources for something that for you has no more value. And you think, oh no, it's just one delete function, but that's not so easy if you don't have the right data structure, if you don't have the right solution. Deleting a large amount of timestamp data needs to be efficient and needs to be integrated in your solution. And that cannot be like someone remembers, oh, now I need to do a deletion or create a script to do it, handle it like a head up. No, it needs to be part of your platform. You need to be able to set up a retention policy right from the start. So you don't have to worry about ingesting a lot of data and later on seeing, well, when are you going to get rid of it? It will be part of the life cycle of that data that is automated. So here is just to give you a better visualization of what it means to be a platform. So Influx Data is an open source solution, yeah. And here in the bottom, you can see what that platform is comprised of. We have 4 major projects very much alive in the community. The core one, the most important one, of course, is Influx DB, is the purpose-built time series database. But Influx DB also comes along with Telegraph, which is the collector agent that makes sure that we collect the information in the best possible way to be ingested, processed, and stored. Chronograph is another very exciting project, and it is about the observation part of it. Chronograph comes with already pre-canned dashboard, so you can from start you can already get a feeling of what's going on, to be familiar with the platform. And the fourth element is capacitor. Capacitor is the real-time string processing engine, and this is extremely important for learning, for machine learning, for getting a fast reaction to what's going on in your environment. And from the first letter of each one of those projects, we have what we call the tick stack. And sorry. And on top of the open source, InfluxData as a company offers service, of course, to generate some revenue so we can maintain our happy engineers, which are very, very in love with the open source project. So most of our engineering team is actually working on the open source rather than on the enterprise of our cloud offering. But we understand that companies, they need to have some kind of assurance in terms of how the solution works, and we provide that layer with clustering, with manageability and security on top of the open source. So here is a view of the architecture, so you can understand better how things talk to each other. On the left side, we have Telegraph. That is our wonderful agent, and it is there collecting everything that you need to collect. So Telegraph has more than 200 plugins to any kind of solutions that is out there in your current environment. We collect metrics from the system stacks, you get applications and databases that you have that in your network. We collect networking parameters as well. Telegraph also ingests and outputs data from message queues like Kafka, and also logs. Telegraph also gets the log files and passes it and sends it to Influx in a format that is ready for time series processing. And the important thing to understand about Telegraph is that it is compatible, it is capable of collecting data in both ways: metrics, regular data that you pull from interfaces that are exposed from third party, but also listen to data that is being published for Telegraph to collect. Yeah, so we have listeners, so we can receive pushed kind of time series data, but also collect data. And that is not, I would say, across the board in terms of solutions that's out there. So you do need to pay attention about that kind of requirement. For example, Prometheus, it is a very good, it's an excellent monitoring tool, but relies only on pooling. And there are lots of companies out there that actually avoids that kind of collection of data, because you can really claim your bandwidth, your network bandwidth, with regular pooling of data, of interfaces. And so you need to have the option also to push when it makes sense and to pull when you need. Let's see. So we have Chronograph. Yeah, that's the visual interface. So you can query Influx DB, and the query language is something that it will look familiar. It has like SQL kind of syntax, so you don't feel like a barrier up front. It's human readable, so it quickly can start understanding what's going on and performing your own queries. And we have Capacitor also talking to InfluxDB. Capacitor can receive data real time from Telegraph, but also pull data, a little colder data, historic data from InfluxDB for aggregation and data analytics that you need in order to generate the next level of insight. And Capacitor is a key aspect of your strategy, your time series data strategy, because that's the engine that will feed a lot of the intelligence that you are going to create from the data that you're collecting. Yeah, because why collecting so much data and paying so much storage and have so much trouble and make sure that you get everything if you cannot extract the most of it? Let's continue. So here let's list what describes InfluxDB. The InfluxDB is a database of this platform, data time series data platform. First, InfluxDB is extremely easy to get started with, and from my own experience, you just go to the download site, you download, install, 5 minutes later, you have it running. I think you have just one configurable parameter there, and that's it. The query language, as I mentioned, is very familiar and human readable. So you can start your time series project, very easily. In 5 minutes, you feel like, okay, I'm empowered to do this. I can start collecting metrics, and I can start seeing how this can help me to make decisions. There is no external dependency, so one binary you install and you're going. Allows for regular and irregular kind of collection, as I mentioned before. InfluxDB will happily receive your metrics or your events. Another important aspect is that in the way that InfluxDB was designed, it allows for horizontal scalability. So you can add nodes and nodes in your cluster, so you can handle more and more of the data that you are collecting. It was made to scale, and it's as we just talked about, it's a member of a cohesive platform. So it's not just about the database and the time series storage engine. It's about collecting it in the way that you need, about visualizing the data, and about interfacing with streaming processing engines. So, but in order to be an efficient and effective time series solution, you have to start from the right place. And the right place to start is to understand the data model, because once you collect the data in the right format, you can better handle it for real-time analysis and also long-term storage. So here is just to start getting familiar with what is a point in InfluxDB. So you see these 3 lines there and the highlighted point. This is all one point. InfluxDB, it has an inline protocol that it is defined as you have it here. It's comma separated and space separated, but you will have a measurement. You have a tag set, a field set, and a timestamp. The measurement is what, let me show back. The measurement is what you care about. What is the thing that you want to observe? In this case here is the stock price. Okay, I'm going to be back and forth because it's easier for you to understand. The tag set is what you're going to collect to make your life easier when you want to query that data, when you want to find out anything about that data. So the tag set is the metadata. In this case here is you have 3 different kinds of tickers, and that you need to, when you collect the stock price, you need to be able later on to identify for which stock you are collecting that information. So the tag set is what helps you, is the contextual data about what you are monitoring. And notice that's called a tag set because you can collect as many as you want, as you find it, useful. And then you have the field set. The field set is actually the information or the metric or the value that you are going to monitor. Is the price, is the stock price. But Again, notice that it's field set. You can collect more than one metric or value that you want to monitor. In one message for collection message, you can have multiple field set, and this is very cost efficient in terms of collecting the data. If you are there with your IoTs, with very limited resource, and then you collect everything at once and bring it over in one shot over the network, whatever network you have there, and maybe, by the way, a satellite link or cellular link. So you need to be efficient about that. And of course, the timestamp. Here is just to give you another example so you can visualize a little bit better what's going on. So using the line protocol, what we have, as I said, is the measurement, the tags, common tag set, space field set, space timestamp. So let's see in this example here, which is more related to networking monitor, infrastructure monitor. Let's say that what you care about now is the CPU load. So that is measurement. Think of measurement like a table, where you're going to put the information that you care about, that specific parameter. So the measurement is CPU load, and tag sets that you could think of collecting is, okay, where is this CPU? So you want to collect the host name. So you have so many different data centers, infrastructure all over the place, so you may also collect information about the geography. That's your tag set. And then the field set. Okay, since I'm checking into this, what I could get as information for that timestamp that I'm giving it. In this case, in this example here, the two types of metrics or values that will be monitored by this measurement is temperature and volt. But you could have as many as you want. There is no limitation, and that's a huge advantage of the Influx data model. It's flexible. The schema is flexible. You can start with one, you can change later. You need to pay attention to the term flexibility, because there are some solutions in the market that also allows you to collect metadata. And collecting metadata is already an advantage. Believe there are solutions there that don't allow you that. But there are solutions that allow you to collect metadata, but in a very hard hierarchical structure, where once you set that metadata, first for you to query, you would have to use full text. How expensive is that when you have sampling rate of nanosecond? So here, the tag set is collecting key value pairs, and can be indexed. So you can do your query very efficiently. And if you want to change later on the number of tags that you want to use, you can. Nothing is really set in stone. So back to our graph, here we have it. We have, you're collecting stock price, that's your measurement. The price is your field, and you have, from that collection, you can generate 3 different series, because series are a set of points that share the same measurement or tag set. So for that same measurement, collecting price, you can dive into 3 different series. You can monitor 3 different series based on the metadata that you collect. In this case, was the ticker. The ticker could be along with it also. You want to dive deeper in looking into the data. You could add also, in which stock exchange market you have that ticker price collected from. So let's continue. So here, just talking a little bit more about the inline protocol, because it's so flexible and gives you so much power in terms of what you're collecting and how you're collecting, because this will impact your performance in terms of ingestion rate and the I/O. If you collect things separate and different measurement, it's still I/O there. So you have consequences on every single decision that you make about your time series. you pay big time if you make it wrong, because we are talking about volume. You don't think small, you think big. So you may think that you can afford, I can be a little bit inefficient here because I just want to collect this. But think in a platform strategy. Think that you are serving many different kind of audience. Think that you will have, a list of requirements from business units about, the big data kind of analysis that they are doing, and you need to provide, indices that will help them to make that analysis, and you'll be collecting data and you'll be storing data. So you need to be smart about, a solution that gives you a data structure that is efficient. In this case here, just to show how flexible it is, that you don't, in the second line, in the second sample here, you don't even have this timestamp. It's okay. In certain situations, you may not be able to collect the timestamp, or you don't want to collect the timestamp, or the timestamp didn't come with it. But in the database, you have that option to include the timestamp when you write to the database. So I hope from this, I would say, high-level explanation about, open source. I think this is the beginning of a conversation, of open source and purpose-built. I could give you an idea of kind of things that you need to consider when thinking of your time series strategy. Think big. Think that you're not serving only yourselves. I think in the audience we have a lot of those anonymous heroes in the back there, making sure that myriad of devices and networks and different kind of application pulverized in microservices work fine. And I congratulate you. But think that you, on top of all of that, you will serve other purpose, like business units trying to understand how they are doing, and you will enable your company to provide different services when the time series itself is the value proposition. So that's what I had for today, and I'm open to questions.
Great, thanks so much. We do have a few questions that have come in. The first question that we have is, can I contribute to these projects?
Pardon, I didn't get it.
The question is, can I contribute to these projects?
To the project?
Yes.
Yes, sure. It's an open source. In GitHub, you will have all the 4 projects: Telegraph, Chronograph, Influx DB, and a capacitor. And it's a very exciting community. It is open to your questions, to your concerns, to your needs. And if you have something to contribute with, it will be very welcome, because it is a market that is learning from itself yet. It's an enabler, it's a supporter, and there is a lot of consideration that needs to be done in terms of how much can I use of current legacy solution I have out there, how I can integrate with existing monitoring system, because you are not going to get rid of everything that you have. The transition is slow, but you may want to start using a platform strategy in a very, I would say, conservative way. Okay, no, I just want something to take the information that I get from Prometheus and put in a truly scalable solution. And then you use Influx DB as your long-term storage. So there is opportunity for contribution, and it's very welcome.
Awesome. The next question that we have is, can I use Telegraph with a different database?
Telegraph with different database? Telegraph, it does the parsing to the inline protocol that InfluxDB understands. If you have a different database that understands the data in that format, yes. But Telegraph also can be placed in front of a message bus and after a message bus. So You can play with Telegraph in many different ways, and the plugin community is out there, creating new ways of communicating from and to Telegraph. So what I would say is I would encourage to check, the Telegraph community. The number of plugins is way beyond 200 now, and they are actively working on it.
Great. The next question is, why can't I use a relational database for my time series data?
You can, as you can use, Cassandra and Elasticsearch. You can even use Excel, believe me, because as long as you can query on time is a dimension that you collect to store and is available for querying. Yes, but how well you can do this? If you have the proposal for a purpose-built kind of solution is that when we store the collection of data that you get, we store it in a smart way. We know that we are monitoring the same thing over time, like a second later. So when you get that information, first you get it, of course, hot in memory to do the real-time analysis. But as you pass along to a file that's going to be stored, the way that this information is stored is like keeping all together with your time as a column, grouping all that sample. So when you come and ask a query about a specific series in a range of a day or week, it goes there and easily find that chunk. So it's all about being fast and efficient. You can use different tools for sure, and we saw the graph. 65% still use relational database. 18% are trying to use just NoSQL. Whatever they are familiar with, and they will get by for a while. But think big. Think when you get all these requests for monitoring things, for providing indexes, and how we are going to deal with that volume in speed.
Great. The next question that we have is, what are the advantages over RDBMS?
Over our relational database? That's the same question as before. The relational database, it doesn't keep the time as your hook for storing the data and for finding that data together. So in a time series database, and I'm going to talk about Influx DB architecture, what you do is you get that information about a series, and you keep in chunks, and everything that you do with that data is based on shards, and the shards are time bound. The files are time bound, and when you get a query with a time range, you have an index that shows the measurements with the tag set pointing to a place in a file where you get that. So it's quite efficient and fast. When you are talking about the time series database purpose-built, we are talking about, let's say, hundreds of millions of series handled. Okay, you are talking about millions of writes per second. You're talking about thousands of queries per second. Can you do that with a relational database? Think about in that way. Think about in that kind of numbers.
Great. The next question that we have is clustering available in Influx DB?
Clustering is, you are welcome to do clustering in an open source environment, but clustering is usually requested by large companies that have commitments for zero downtime, and they need to rely on a service for that. So clustering is part of our enterprise service and cloud service, and that is a paid service. But yes, yeah, you can use Influx DB, and you can do your sharding, you can do your clustering in an open source way.
Great. The next question that we have is, how efficient is a real-time time query with millions of data samples?
Excuse me, I didn't get it. I have a little bit of an echo. Can you say it again?
Yes, the next question is, how efficient is a real-time time query with millions of data samples?
Yeah, this is a benchmark. I would not know how to give you a direct answer now, but I would be glad to take to our engineering team and come back with the appropriate answer. But we have in our website lots of benchmarks done against, the traditional database, and also the database that are, today like that has a market today, market representation, like Elasticsearch. We have a benchmark against them. We have other benchmark against Timescale, against Cassandra, and you can see how the two of them compare when you deal with time series.
Awesome. The next question we have is, how is Influx Data compared with Grid DB or Timescale DB?
What was the first one?
Grid DB?
Great. I will double check the first one. We do have a benchmark with the Timescale. So Timescale, they use a relational database underneath. They use SQL, and they come from a different starting point. Okay, they are time series, but they are, would say, not totally purpose-built in that way. Influx Data thought about time series from the ground. We thought about, how we are going to collect that data, how we are going to transfer that data in a format that we can easily process upfront and store for historical purpose and allow for fast queries. So I think that's the main difference. But we do have a benchmark made with the Timescale to give you an idea in terms of performance.
Awesome. It looks like we have time for one more question. Last question will be, is there a benchmark between Influx Data and Druid?
Druid, okay. I have not seen it. I've seen Cassandra, and I've seen Timescale, I've seen Elasticsearch, and I've seen Graphite RDD that is based on RDD legacy. But Druid, I have not. I will have to take a look and see if the engineering team have done something in that aspect.
Awesome. And with that, Daniela, I would like to thank you for a great presentation. I would also like to thank today's sponsor, Influx Data, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.
Thank you all.